In this video, we'll learn about dilutions of solutions. So the formula that we can use for diluting is M1V1 equals M2V2. And just a way to think of this is M being molarity, that's moles per liter. And so if you have moles per liter times volume, which is also in liters, is equal to moles per liter times liter on the other side, what we find is that the liters cancel. And really what we're left with is that the initial number of moles that you have in a solution are equal to the moles that you have at the end, which should probably make some sense because, well, let's look at the simulation. Currently, we have some potassium dichromate in solution, and the concentration is 0.200 moles per liter. Now we have half of a liter, so if you multiplied half of a liter times 0.200 moles per liter, you'd find that there are 0.100 moles of potassium dichromate in this solution. Now, let's say we add some water, and let's stop at, oh, there we go, exactly 1 liter. Well, our new molarity is 0.100 moles per liter, and our new volume is 1 liter, and note that the same 0.1, or I should say the same molarity times volume being equal to 0.100 moles holds in this case. And that should make some sense because the moles of potassium dichromate that were there initially, when there was half a liter, are the same as the moles that are there now. We have not changed the moles of potassium dichromate. We've simply added water. And so that's how you can calculate with dilutions of solutions. So here's a practice problem. How would you prepare 1.0 liters of a 4.50 molar solution of H2SO4 from an 18.0 molar stock solution? Let's give it another sig fig, call it 1.00 liters. Anyway, we can do M1V1 equals M2V2. We take our stock solution of H2SO4 at its initial 18 molar concentration. And the question that we're really asking ourselves is, what volume of that concentrated 18 molar solution are we going to need to add water to eventually dilute to a volume of 1 liter with a molarity of 4.50 moles per liter? If we did out the math here and divided both sides by 18.0 moles per liter, we would get that our volume is 0.250 liters. And so what this indicates is that we'll need 250 milliliters, or 0.250 liters, of that 18.0 molar stock solution. But first, we add some water to a 1 liter volumetric flask, and then we slowly add the calculated amount of 18.0 molar sulfuric acid. We add the acid to the water for safety's sake so that we're not releasing a ton of heat that ends up causing the concentrated acid to spit in your face. Then from there, we can just dilute to the mark on the flask, and we'll have our 4.50 molar solution of H2SO4 with a volume of 1 liter, 1.00 liters. And in that solution, there will still be the same amount of moles of H2SO4 as there were in the initial 250 mils of the 18.0 molar stock concentrated solution. Hope this video has helped. Feel free to leave any questions or comments in the comment section below. Thanks for watching.